We continue with part 3 of the video. In the last video, I demonstrate to you how to calculate the F value. So in this video, example 5, I will show to you how to conduct the hypothesis testing by using the p-value. We are still using the same example, the 3 methods used in teaching statistics. But this time, you are given a statistical output. And you have to test at 5% significant level the claim that there is no difference among the population means. Let mu1, mu2, and mu3 be the mean score of student taught by method 1, 2, and 3 respectively. So we have step number 1, we state our null and alternative hypothesis. Our null and alternative hypothesis mu1 equal to mu2 equal to mu3. And alternative hypothesis, at least one population mean is different. Step number 2 is to state your alpha value. Since your significant level is at 5%, then your alpha value is 0.05, and then you have to write your decision rule. For p-value, you only have one decision rule, which is if p-value is less than alpha 0.05, then you have to reject the null hypothesis. Step number 3 is to state your p-value. Where do you get your p-value? You have to refer to your statistical output. Based on the output, the p-value is 0.366. So you have p-value 0.366. Next is to compare your p-value with the alpha. Since your p-value 0.366 is greater than your alpha value 0.05, then we fail to reject H0 or we do not reject H0. So this is your step number 4, your decision. And last one, step number 5. Since you do not reject H0, then there is insufficient evidence at 5% significant level to conclude the alternative hypothesis. Example 6. A consumer agency wanted to find out if the mean time taken by each of 3 brands of medicines to provide relief from headache is the same. The following table gives the time in minutes taken by each patient to get relief from headache after taking the medicine. So the experimental unit in this study is the patient. What we impose to the patient? We impose the medicine or the treatment to provide relief from the headache. So here, the treatment is the medicine to provide relief from headache. We have 3 levels of treatment with factor, drug 1, drug 2, and drug 3. The response variable or variable of interest in this study is the mean time taken for drug 1, drug 2, and 3 to provide relief. Since we only have one treatment with 3 groups, group 1, group 2, and group 3, therefore one-way ANOVA is appropriate in this study. At 2.5% significant level, will you conclude that the mean time taken to provide relief from headache is the same for each of the 3 drugs? So this is the purpose of the study. We want to compare the population mean. To conduct the hypothesis testing for one-way ANOVA, we first have to calculate the sum of square. I always start with total sum of square. The total sum of square is given by summation x square minus summation x, the whole thing square divided by capital N. I'm sure you know how to obtain all this value by using the scientific calculator. By using the calculator, you will have the value of summation x square equal to 28979 Summation x is 585 and capital N equal to 14. You replace all this value or information into the formula, then you have 28979 minus 585 square divided by 14. You will have 4534.3571. Next, we move to treatment sum of square, SSA. In treatment sum of square, you have to first obtain the total time for each of the group. For group 1, to obtain T1, you have to sum all the data point here. And you will have 2, 6, 3. And the sample size of group 1, you have 1, 2, 3, 4, 5, 6. Same goes to group 2, T2, you have to add all the data point here and you will have 83. And the sample size of group 2 is 4. For group 3, you sum all the data point here, you will have T3 equal to 239 and the sample size N3 equal to 4. You replace this value into the formula, then you will have 263 square over 6 plus 83 square over 4 plus 239 square over 4. For the second term of the treatment sum of square, it is the same as total sum of square. So I just replace the value. We have 585 square over 14. And we solve this one, we will have 3086.0238. All the value that I have here, I will put into the ANOVA table. Total sum of square is 4534.3571. Treatment sum of square 3086.0238. We subtract these two values, 4534.3571 with 3086.0238, we will get the sum square error, 1448.3333. The degree of freedom. The degree of freedom of the treatment is K minus 1, number of group minus 1. Since we have 3 group minus 1, then we have 2. Degree of freedom of error, we have capital N minus K. Capital N is 14 minus K, then we have 11. And the total is capital N minus 1. 14 minus 1, we have 13. How to get mean square treatment? You will get the value of mean square treatment if you divide the sum of square treatment with the degree of freedom. So 3086.0238 divided by 2, you will have 1543.0119. Same goes to the mean square error. If you divide these two values, then you will have the value of MSE. The value of MSE is 131.6667. F calculated is obtained by simply divide these two values. And the value of F calculated is 11.719. Next is to complete your hypothesis testing procedure. Step number 1 is to state your hypothesis. Let we define the parameter first. mu1, mu2, and mu3 be the mean time taken to provide relief for drug 1, 2, and 3, and this is the variable of interest. your null hypothesis is always going to be population mean 1 equal to population mean 2 equal to population mean 3. And the alternative hypothesis, at least one population mean time taken is different. Or you can write in a word for null hypothesis, the population mean time taken to provide relief from headache is the same for each of 3 drugs. And alternative hypothesis, the population mean time taken to provide relief from headache is not the same for each of 3 drugs. Step number 2 is to find your critical value. Your critical value is given by F, alpha, degree of freedom of numerator, and degree of freedom of denominator. Your alpha is 0.025, degree of freedom of numerator is 2, and degree of freedom of denominator is 11. And if you refer to your F table, you will have the value of 5.26. Your decision rule is you reject H0 if your F calculated is greater than your critical value. Step number 3 is your test statistic. Based on your ANOVA table, your test statistic is 11.719. Then step number 4, you compare your F calculated 11.719 with your critical value. Since 11.719 is greater than your critical value 5.26, then you reject H0. Your conclusion should be, since you reject H0, then you have enough evidence at 2.5% significant level to conclude your null hypothesis. We proceed with example 7. In example 7, we have the Minitab output from the data that we have in example 7. And they want us to conduct the hypothesis testing, but this time we are using the p-value with alpha 0.025. When we look at the output, we have to look at the number of group. The number of group here, we have 3 group. Group 1, drug 1. Group 2 is referred to drug 2, and group 3 refer to drug 3. So to state the hypothesis, the null hypothesis, we have population mean 1 equal to population mean 2 equal to population mean 3. And alternative hypothesis should be at least one population mean time taken is different. Alpha. What is alpha? Alpha is 0.025. The decision rule is we reject H0 if p-value is less than alpha. P-value. Based on the output, we have p-value 0.002. We compare p-value with the alpha. P-value 0.002 is less than alpha 0.025. Since p-value less than alpha 0.025, then the decision is to reject H0. Since we reject H0, therefore we write a conclusion as there is enough evidence at 2.5% significant level to conclude our null hypothesis. When we compare the result from the p-value and the F calculate that we have here, we can say that the result is consistent. In example 8, we have a different kind of question. In this example, they want us to complete the ANOVA table. To complete the ANOVA table, we can start with the column degree of freedom here. How to get the degree of freedom for the treatment? Okay, we look at the statement here. We have the 4 independent population, means that we have 4 group. 4 group minus 1, then the degree of freedom of the treatment is 3. Next is to find the error sum of square. Recall that the formula of MSE is given by SSE divided by the degree of freedom. To find the value of SSE, we simply multiply the value of MSE, which is 9.2154, with the degree of freedom, which is 14. We multiply these two values, we have 129.0156. Next is to find MSA. We have the denominator value here, 9.2154. So to find the MSA, we multiply 9.2154 with 4.07. And we have MSA equal to 37.5067. For SSA, we apply the formula of MSA equal to SSA divided by the degree of freedom. MSA is given by 37.5067. We multiply with the degree of freedom, which is 3, and we have 112.5201. So this is the complete ANOVA table. We move to question B. Using alpha 0.05, what is your conclusion for the test with the null hypothesis that the means of the 4 populations are equal against the alternative hypothesis that the means of 4 populations are not equal? So our null hypothesis, the mean of 4 populations are equal, and the alternative hypothesis, the means of 4 populations are not equal. The critical region or the critical value, how do we get this value? 3.34. We have F value, F alpha is 0.05, and the degree of freedom of numerator, which is 3, and degree of freedom of denominator, which is 14. By looking at the F table, we will get F 0.05, 3, 14 equal to 3.34. The F statistic is 4.07. Since 4.07 is greater than critical value 3.34, which is fall in rejection region, then we reject H0. Since we reject H0, then we can say that we have enough evidence at alpha 0.05 to conclude our alternative hypothesis.